So today is going to be the last day where we look at 4.1 quadratic functions, just this section. We're looking at something a little bit different, finding the equation of a parabola of a quadratic function when we have the vertex and perhaps a point or something else that we know about the graph. So here we know that the vertex is 2, 7, and if you remember, HK represents the vertex. So that's 2, 7. And we have a point through 4, 3. So we can say a point x1, y1 is 4, 3. So let's just look generally at our quadratic function in vertex form. F of x equals a times the quantity x minus h closed quantity squared plus k. We already know x and k. So actually the only thing that we need to figure out right now is a. And here's how we're going to do that. We can substitute 2, 7, our vertex, in for h and k. So we know this is going to be, we can also call this a y, equals a times x minus 2 squared plus 7. Substitute 2 in for h and 7 in for k, and we get this, and we want to find a. So now what we're going to do is substitute x1, y1 into this function. Remember, y and f of x are really just two ways of saying the same thing. So when x is 4, this should make y equal to 3. So now we have this function here. 3 equals a times the quantity 4 minus 2 closed quantity squared all plus 7. And this is something we can solve for a. So 4 minus 2 is 2. So we get 3 equals a times 2 squared plus 7. Then I can square the 2, which is 4. So 3 equals 4 times a plus 7. And hopefully this is an Algebra 1 problem for us to solve at this point. We'll subtract 7 from both sides, giving us negative 4 equals 4a. And we can divide both sides by 4, which tells us that a is negative 1. So now I'm going to come back up here and put negative 1 in for a, because at this point all we needed was a. So we know the correct function for this is y equals negative 1. I'm just going to leave it as a negative sign, times the quantity x minus 2 closed quantity squared plus 7. And this should be my answer. I'm pretty confident that we do have a vertex of 2, 7. We really just want to make sure that the point 4, 3 is on this graph. So then as I check this, y equals negative x minus 2 closed quantity squared plus 7. It would check out based on this graph that vertex is probably 2, 7. So then I just want to notice the point 4, 3 happen here. So 1, 2, 3, 4, kind of tight. 1, 2, 3. That's about right. 4, 3 would be somewhere right about here, which is where that graph is. So feel pretty confident there. That looks right. I think we did that correctly. And then same thing on Desmos. If we check y equals negative quantity x minus 2 closed quantity squared plus 7. We've got a vertex here at 2, 7. That's for sure. And then here is the point about here is where we would find 4, 3. Wonder if we can do that here. I bet we can. 4, 3. Yep. So by also adding the point 4, 3, we can see that 4, 3 is on this graph. So we have a vertex of 2, 7 and a point of 4, 3. Okay, and then one last one. So this is a word problem, but we're going to work it out the same way we just did. A soccer player kicked a ball that reached a maximum height of 7 feet and traveled 20 feet. So you can see a ball that gets kicked should travel roughly in the shape of a parabola based on gravity and some other factors. So then halfway through the flight of the ball, it should reach its maximum height at 7 feet in this case. It traveled a total of 20 feet, so halfway across would be 10 feet. So what I can tell from here is that the vertex, let's say we call the point where the ball starts the origin at 0, 0. That means the vertex here occurs at 10, 7. And then it hits the ground again after 20 feet, so that could be the point 20, 0. So now we want to write a function that models the path of the ball. So generally, we know the vertex hk is at 10, 7. And we're looking at f of x equals a times the quantity x minus h closed quantity squared plus k. F of x is really just the same thing as y. So y equals a times the quantity x minus 10 closed quantity squared plus 7. I can just substitute the vertex in here. And then we can use this and one of the points that we know on this graph to solve for a. I can either use 0, 0, the starting point, or 20, 0, the ending point. Both of those are fine by me. I'm going to use 20, 0 in this case. So x is 20 and y is 0. So a times the quantity 20 minus 10 closed quantity squared plus 7 is 0. 20 minus 10 is 10. That's supposed to be a 10. Squared plus 7. 0 equals 10 squared is 100. A plus 7. And then we can subtract 7 from both sides. Get negative 7 equals 100a. Divide both sides by 100. And if you need to double check that, negative 7 divided by 100 is negative 0.07. So then I'll substitute this value of a, oops, not there, back here, where all we needed was the a value. Y equals negative 0.07 times the quantity x minus 10 closed quantity squared plus 7. So that is one function that can model the flight of the ball there. And that should be everything for us in Chapter 4, Section 1, Quadratic Functions.